So for this video, I will be discussing question 1, which is the coding question on the first test for Section M, Spring 2014. So when you first get to the problem, you realize that it is a coding question. And the coding question involves gravity and air resistance. These are two topics that we discussed in previous labs, so there is some knowledge of it. However, as you can see, the object is not flying straight down. Instead, it is flying at an angle. So after we read the problem, the key points we took out is the initial velocity is 15 meters per second, and it is at an angle of 20 degrees from this line. Therefore, we can do some trig to get the components of the velocity in the y direction and in the x direction. So what I do when I start coding problems is that I draw a picture. So we know it's coming in at this angle, 20 degrees, and the velocity is 15 meters per second. So therefore, to find this x component, that's opposite over hypotenuse, which is sine. So sine of 20 equals x over 15, and this x is going to be this component. And we know y is adjacent over hypotenuse, which is why it is cosine 20 equals x over 15. So then we just simply put it into a vector. So once you put it in the vector, you have to write vector 15 sine 20 is the x component, negative 15 cosine 20, y component, and 0. There is nothing in the z direction. In addition, you have to put the negative sign in front of the y component because the pelican is flying downwards, which is in the negative y direction, and the x is obviously flying in the positive x direction, going this way. So once you get the problem, you get some initial information. You know the gravitational acceleration is 9.81 meters per second. You have to make it negative because the bird is flying downwards, and you know the b constant. So in this problem, we have to update the position. So we have to focus on Newton's second law. First of all, we have to find the final velocity. So we know in physics class that the final velocity is the initial velocity plus F net divided by the mass times delta t. But now we have to put this in coding. So we know the pelican's velocity is pelican.vel. We have to use this the whole problem, equals pelican.vel plus F net divided by pelican.m. We have to use that because it is given right here, times delta t. But now we have to update the position. You know the final position is equal to the initial position plus velocity times delta t. Now we have to change this into coding. So we know pelican.pause equals pelican.pause plus pelican.vel times delta t. And we know pelican.vel right here based on right here. So we have to put both of these equations into the coding program in order to get the right answer. So after looking at the equations, we have to figure out what is missing. We know the mass, we know the initial velocity is 0 because it starts from rest. So we're missing net force. Now we have to think about the forces that are acting on the bird. We know the earth is acting because of gravity, and we also know drag force is acting on it because it is flying through the air, so obviously that naturally occurs. Now we have to focus on the earth. We know nothing is in the x direction and nothing is in the z direction. However, there is something in the negative y direction. In this case, it is mass times acceleration, and it's negative because it points downwards. So we can make the net force vector for earth equal vector 0, and then negative 9.8 times pelican.m, or we could just have made this g and then 0. Now we have to focus on the net force for the air, which is the drag force. We must use b, which is given, and we don't have to write it out, we can just use this. And it is proportional to the speed cubed. So we have to find the magnitude of speed. So to find the magnitude of it, you do magnitude of velocity, that gives you the speed, and then we have to cube it. And then we plug it into the equation, we get the vector 0, negative b, because it points downwards, of the magnitude of the pelican.vel cubed, which is what these two stars mean, and then 0. And now to find the net force, you simply add them both up. So you get the net force, F net equals F earth plus F air. And then once you put all the steps I gave you into the problem, it should produce the new updated position. Thank you.